From 12 to 16, it is 25 megawatt. 16 to 20, 35 megawatt. 20 to 24, 20 megawatt. So this is the data which is given in the question. Now they are asking us. Now they are asking us to draw the load curve. They are asking us to draw the load curve first. Then they are asking us to find the maximum demand. To find the maximum demand, we have to find out what is the maximum demand. Then units generated per day. Then we have to calculate units generated per day. After that, we have to calculate the average load. The daily average load. Here, the average load stands for daily average load. Then finally, we have to calculate what is the load factor. So these are the parameters which we have to find out. So they have given the question. From the given question, we have to find out all these: maximum demand, units generated per day, average load, load factor. Okay. Now let us solve this. Now let us solve this. Solution. So first we have to draw the load curve. First we have to draw the load curve. So what is load curve? First of all, what is load curve? In load curve, at the x-axis you will have your time in hours. How about your y-axis? In your y-axis you will have the load or demand. Load or demand, it can be either in megawatt or in kilowatt. So load curve is a graph. Basically, it is a graph. So let us draw the load curve now. Let's draw the load curve. So in x-axis, right, we will have time in hours. Let me start at 0 hour. Then 2, 4, 6, 8, 10, 12, 14, 16, 20, 22, say finally I have my 24, because in a day I will have 24 hours. In a day I will have 24 hours. Right. Now in y-axis, what I will have in my y-axis. So in my y-axis, I will have in my load, that too in megawatt. Why in megawatt? Because in the question, the load is represented in megawatt. Okay. So let me scale it. Say this is 5, then I will have 10, 15, 20, 25, say 30. I have my 35 here. 35. Right. Okay. Now, for 0 to 6 hours, in the question they are given, from 0 to 6 hours, the load is 20 megawatt. So, from 0 to 6, the load is 20 megawatt. So, I have my 6 here. I have my 20 here. So, I can draw a line from 20. From 20 to 6 hours, the load remains 20 megawatt. Right? That is fine. Now from 6 to 10, now I have to go for 6 to 10, it is 25 megawatt. 6 to 10, it should be 25 megawatt. 6 to 10. to 10 it is 25 megawatt. Fine. Then from 10 to 12 it is 30. So 10 to 12. So from 10 to 12 it is 30. Okay, from 10 to 12 it is 30. Fine. Then from 12 to 16, then from 12 to 16 it is 25. So I have my 12 here, then I have my 16 here. So 12 to 16 it is 25. So I have my 25 here. 12 to 16 is 25. Then from 16 to 20, from 16 hours to 20 hours, it is 35. 16 hours to 20 hours. Say this is 18. 16 to 20 hours, it is 35. So I have my 35 here. Right. 16 to 20, say it is 35. Then from 20 to 24, it is 20. From 20 to 24, it is 20. It is given in the question. 20 to 24, it is 20. So I have my 20 here, I have my 24 here. Right. I have my 20 here. So from 20 to 24, it is just 20. So from 20 to 24, it is 20. Right. So now this curve is known as load curve. This curve is known as load curve. Okay. Now we have to find out the maximum demand. Now our goal is to find out the maximum demand. Maximum demand. Right. So we can easily say what is the maximum demand from the load curve. Now let us go for the load curve. What is the maximum demand? Let us search for the peak. So the peak value is 35. Peak value is 35. So obviously my 35, obviously 35 megawatt will be the peak value in load curve. So the peak value in load curve gives the maximum demand, which is 35 megawatt. Fine. 35 megawatt. Okay. Then third subdivision. Let us go for third subdivision, that is units generated per day. So how to calculate the units generated per day? Very simple. In the load curve, or we can say area under load curve gives area under load curve gives units generated per day. So let us calculate the area under the load curve. So what is that equal to? What is that equal to? Which gives units generated per day. So I have to find out this area. So check what is the units generated per day. Okay. Now from 0 to 6, from 0 to 6 to 20 in the y-axis, it resembles a rectangle. So what is the area under rectangle? It is length into breadth. Here the length is say 6, which is in hours, and the breadth is 20, and the breadth is 20, 0 to 20. So 6 into 20, which will give this area. This area. Right. So I will write 6 into 20 plus. Then from 6 to 10, I have the load as 25. So the length becomes 4, whereas the breadth is 25. So 4 into 25. Right. Plus. Then from 10 to 12, from 10 to 12, the length is say 2, whereas the breadth is 30. So 2 into 30 plus from 12 to 16. From 12 to 16, the length is 4, whereas the breadth is 25. So 12 to 16, 4 into 25, right? Plus from 16 to 20. From 16 to 20, the length is 4, whereas the breadth is 35. So 4 into 35, right? Then plus from 20 to 24. So from 20 to 24, the length is 4, whereas the breadth is 20. So 4 into 20. 4 into 20. So this will give my units generated per day, which is area under load curve. 6 into 20, 4 into 25, 2 into 30, 4 into 25, 4 into 35, 4 into 20. So now let us calculate what is the value of this. So this is 600 megawatt hour. I have written as megawatt hour because the load is given in megawatt. We are multiplying it by time. Time is in hour. So the unit becomes megawatt hour. But they are asking us to find the units generated per day. So what is 1 unit is equal to? 1 unit is equal to 1 kilowatt hour. So this has to be converted to kilowatt hour, which is equal to 600 into 1000 kilowatt hour. So this can be written as 6 into 10 to the power 5 kilowatt hour, which is equal to 6 into 10 to the power 5 units or 6 lakh units. So 6 lakh units is being generated day. Then they are asking us to find the average load. Then we have to find what is the average load. So how to find the average load? Average load is given by, so let us say average load is given by units generated per day, units generated per day by number of hours in a day, number of hours in a day. So that is my average load. So that is equal to units generated is equal to 6 lakhs divided by, it is given in megawatt hour, divided by 24, because the number of hours in a day is 24. So the unit will be in kilowatt. So average load is equal to, my average load is equal to 25,000 kilowatt. Now this 25,000 kilowatt can be converted to megawatt, which is 25 megawatt. 25 megawatt. So that is my average load, or 25,000 kilowatts. That is my average load. Fine. Now next we have to find out what is the load factor. Next we have to find what is the load factor. Okay. So what is the formula to find load factor? Load factor is given by, load factor is given by average load by maximum demand. Average load by maximum demand. So my average load is 25 megawatt. What is my maximum demand? Maximum demand is 35 megawatt. Is 35 megawatt. 35 megawatt. So load factor is equal to 25 by 35. 25 divided by 35, which is equal to 0.714. That is my load factor. That is my load factor. Right. So I have calculated my load factor as well. So do you have any doubt in this problem? If you have any doubt, you can ask me. If you have any doubt with respect to this problem, you can ask me. Yes, any doubt? Praveen? Mr. Praveen?
Sir, no doubt.
Mr. No doubt. Is my note visible?
Yes, sir.
Do you have any disturbance in viewing my note? Any problems faced with respect to my note?
No, sir.
Visualizing
No,
my
sir.
note?
It's clear,
No,
sir.
right? So far, it is good.
Yes, sir.
Okay. Now let us solve one more problem. Please take down the problem. So, see problem number 2 for today. A power station has to meet the following demand. Power station has to meet the following demand. Group A, 200 kilowatt between 8 a.m. and 6 p.m. Then group B, 100 kilowatt between 6 a.m. and 10 a.m. Then group C, 50 kilowatt between 6 a.m. and 10 a.m. Then group D, 100 kilowatt between 10 a.m. and 6 p.m. and then between 6 p.m. and 6 a.m. Now plot daily load curve and load duration curve. Load duration curve. They are asking us to plot load duration curve as well. And then diversity factor. We have to find what is the diversity factor. Then units generated per day. And finally, load factor. Finally, the load factor. Okay. Now, first, we have to draw the load curve, daily load curve. So, group A, let us write in 24 hours term. Let us write in terms of 24 hours. Group A, for group A, the demand is 200 kilowatts from 8 a.m. to 6 p.m. From 8 a.m. to 6 p.m. So in 24 hours, it can be written as 8 to 18. Right? So 8 to 18 hours. Fine. How about our group B? So for group B, it is 100 kilowatt from 6 a.m. to 10 a.m. So 6 to 10 hours. Fine. Then group C. How about group C? 50 kilowatt from 6 a.m. to 10 a.m. Same. So 6 to 10 hours. Fine. How about my group D? It is 100 kilowatt from 10 a.m. to 6 p.m. What is 10 a.m. to 6 p.m.? 10 a.m. to 6 p.m. is 10 to 18 hours, and between 6 p.m. to 6 a.m. So in group D, we have two sections. One is 100 kilowatt from 10 to 18 hours, then 100 kilowatt from 6 p.m. to 6 a.m. That is 18 hours to 24 hours. Then from 0 to 6 hours, because it is from 6 p.m. to 6 a.m. So we can write that as 18 to 24 hours and 0 to 6 hours. Okay, fine. Now let us draw the load curve. Now how to draw this load curve? Load curve we have to draw. So 24 hours in my x-axis, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 20 in hours time, right? How about my y-axis? How about my y-axis? Say 50, 100, 150, 200, 250, 300, say 350. Okay. Right. Now from 0 to 2 hours, say from 0 to 2, what is the load? From 0 to 2, what is the load? So that we should see. So from 0 to 2, so 0 to 2, the load is, we don't have our group A load, group B load, group C load, but in our group D load, right, we have from 0 to 2, that is 100. Then from 2 to 4, also we have only our group D. Then 4 to 6 also we have only our group D, which is 100. So from 0 to 6, the load remains 100 kilowatt, right? So from 0 to 6, it is 100. Will remain as 0 to 6, it will remain as 100. Fine. From 6 to 8. So what happens from 6 to 8? Let us check. So this is in group A, we don't have 6 to 8. But in group B, we have 6 to 8, that is 100. In group C, we have 6 to 8, that is 50. Right. How about my group D? I don't have my 6 to 8. Right. So 6 to 8 becomes, so my 6 to 8 becomes 150. It is 150. Yes. It is 150. Right. So from 8 to 10. Now from 8 to 10, what is the load? We have 8 to 10 here. We have 8 to 10 here. We have 8 to 10 here. We don't have 8 to 10 here. And here we don't have 8 to 10. So first three, we have 8 to 10. That is 200 plus 100 plus 50. So the total load is 350. Total load is 350. It is 8 to 10. 8 to 10 becomes 350. Fine. 8 to 10 becomes 350. Then from 10 to 12, we have 200. Then we don't B and C, we don't have 10 to 12. We have our D, so it becomes 300. It becomes 300. 10 to 12 becomes 300. How about 12 to 14? 12 to 14. These two should be omitted. We should include group A. So that is 200 plus group D is also included. Plus 100, it is 300. That is my 12 to 14. Then 14 to 16. 14 to 16. I have my group A, that is 200. I have my group D, that is 100, which remains 300. Then 16 to 18. So 200 plus 100 in group D. So that becomes 300. Right. From 18 to 20, this is omitted. A is omitted, B is omitted, C is omitted. How about my D? D here, that is 18 to 20. It is available. Right. So from 18 to 24, only I have my D, group D. From 18 to 24, I have only my group D. Other groups don't supply or they don't require power from 18 to 24 hours. So it is only 100. So from 18 to 24, we have only 100 as load. 1 minute. Sorry. So from 18 to 24, it is 100. So from 18 to 24, we have that as 100. Okay. So this is my load curve. This is my load curve. Fine. Now we have to calculate our diversity factor. We have to calculate diversity factor, units generated per day, and load factor. Diversity factor, units generated per day, and load factor. Before that, let us draw load duration curve. Our load duration curve. So what is this load duration curve? So what is load duration curve? What is load duration curve? So first we should have first we have to order the loads in descending. Order loads in descending. That is, the loads should be placed in descending order. So what is my maximum load? So first highest load is 350. From the load curve, it is evident it is 350. Then it is 300. Then I have 150, then I have 100. Only 4 loads I have, that is 350, then 300, 150, and then 100. Right? So 350, then 300, then my 150, 350, 300, then 150, then 100. Right? 300, 150, and then 100. Fine. Now, for what duration of time my 350 is active? So what duration of time my 350 load is active? So it is active only for how many hours? 8 to 10. So it is 2 hours, right? 2 hours. It's 2 hours. Fine. 300. How about 300? 300 is active for 2 plus 2 plus 2 plus 2. So it is 8 hours. Totally it is 8 hours. Then 150. How about 150? 150 is for 2 hours. 150 is for 2 hours. Then 100. How about 100? 100 is active for 6 plus 6. 6 plus 6 is 12. Right? 6 plus 6, which is 12. 12 hours. So that is total is 24 hours. We can cross check whether it is 24 hours or not. Total should be 24 hours. Yes, it is now 24 hours. Good. Now let me draw the load duration curve. Right. So say this is 100, this is 200, say this is 300, and this is 400. Here we have load in kilowatt, right? This is in kilowatt. Even here we have to write load in kilowatt. Likewise, here we will write load in kilowatt. Here this is time in hours. So 0, 2, then 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and then I have my 24. So, okay. Now, how about my 350 for 2 hours? 350 for 2 hours, first 2 hours, first 2 hours. Then how about my 300 for 8 hours till 10? For 8 hours. So till 10. Then 150 for 2 hours. I will have my 150 here. See 150 here. That is for 2 hours. Then 100 for 12 hours. 100 for 12 hours. Okay. So this is known as my load duration curve. Even the area under your load duration curve, even the area under your load duration curve is units generated per day. So now let us calculate the units generated per day. So that is my third subdivision. Units generated per day. How to calculate area under load curve, or we can even use load duration curve because both have the same area. Fine. So what is that equal to? What is that equal to? So it is 2 into 350 plus 8 into 300 plus 2 into 350 plus 8 into 300 plus 2 into 150 plus load into hour, 100 into 12. 100 into 12. Okay. So that is equal to dash. It is equal to dash. So that is equal to 4,600 kilowatt hour. Fine. Which is equal to 4,600 units. Right. How about my next subdivision? That is, I have to find my diversity factor. See, I have to find my diversity factor. How to find diversity factor? Sum of maximum demands of individual loads by maximum demand of the plant. So the maximum demand of the plant is 350 kilowatts, which is evident from the load curve. What is the sum? What is the maximum demands of individual loads? So that is equal to, for group A, it is 200. Group A it is 200 plus. For group P it is 100. For group C it is 50. Then for group D it is 100. That is the maximum demand for individual loads divided by the maximum demand of the whole power plant or the power system, that is 350. Both in kilowatts they will get cancelled. Now this is equal to dash. So this is equal to 1.286. Fine. Now we have to find out what is the load factor. So what is the load factor equal to? Average load by maximum demand. So how to find average load? Units generated by 24. What is the units generated? 4,600 divided 4,600 is the units generated by 24. Will give the average load. By maximum demand is 350. So this will give my load factor. So my load factor is equal to 0.548. That is my load factor. How did I calculate my average load? Average load is equal to units generated by 24. Units generated is 460 by 24. Will give my average load divided by maximum demand, which is 350, will give the load factor, which is 0.548. So we are done with the problem. If you have any doubt, you can ask me. So far, if you have any doubt, you can ask me, or else you can leave. Google Priya, you can post the attendance and late comers list in the WhatsApp. You can individually WhatsApp me the attendance, that is the absentees as well as the late comers list. Google Priya,
Okay,
will
sir.
you do that for me?
Okay, sir.
Okay. If you have any doubt, you can ask me, or else you can leave. Thank you.